Hello and welcome to this project on plant disease detection. In this project, we will create a convolutional neural network that will be able to predict whether a plant is suffering from a disease or not. We will be using different layers and other hyperparameters for building, training, and testing this classification model. This model is mainly built using TensorFlow and Keras. Now let's see what are the steps we use to solve this problem or to make this project. So firstly, I will teach you how you can mount your Google Drive on Colab Notebook. It is useful because you only need to upload your data on your Google Drive and you can directly connect it to your Colab Notebook. Second, we will visualize how the images look that we are working on. The images that we have, the dataset that we have, we will visualize that. After that, we will find out the means of all the dimensions and resizing them according to the images. Next, we will convert the images into a NumPy array and we will normalize all the images. This is important. Next, we will check the class imbalance, if the data is divided equally in the classes or not. After that, we will split the data and perform one-hot encoding on the target feature, that is the number of classes. Next, we will create the model architecture and compile it, and then finally we will fit the model using the X-train data, Y-train data, and also use the validation data. After that, we'll plot the accuracy and the loss against each epoch to see how the model works, how the model is learning. Then we will move forward to pre-process the test data and use it to make predictions. In the end, we will visualize the original and the predicted labels for the test images. So what is the use of this project is that currently human society needs to increase the food production by an estimate of 70% by 2050. And it is predicted to be over 9 billion people. Currently, infectious disease reduce the potential yield by an average of 40%, which means that out of 100, we get only 60% of the crops that are yield every year due to infectious disease. And the widespread distribution of the smartphones among crop growers around the world, with an expected 5 billion smartphones by 2020, offers us the potential of turning the smartphone into a valuable tool for diverse communities. So what we can do is, this project can be converted into an app which can be used by different farmers to diagnose whether their plants are going through any diseases or not. So that is the main use of this project. This project will revolutionize the agricultural industry. So now let's move forward and see how we can make this project.